Clopidogrel, sold under the name Plavix, is a second-generation antiplatelet drug belonging to the thienopyridine family. Clopidogrel works to reduce the risk of stroke and other cardiovascular diseases by inhibiting platelet clot formation. Clopidogrel is an oral formulation, often taken alongside aspirin for maximal efficiency. A typical Clopidogrel formulation contains 75 micrograms of the drug itself. The drug has a long onset time of around 2 hours, however the desired effects can last for 3 to 5 days. Clopidogrel was designed in 1977 and patented in 1982 in a joint venture by Sanofi and Bristol Myers Squibb Co. The drug was FDA approved and released onto the market in 1997, where it was very successful. Before its patent expiry in 2012, it was the second best-selling drug globally, and in 2010 grossed over $9 billion.
The synthesis of clopidogrel can be completed by many different reactions. The one that is shown is generally considered to be the most effective method as determined by Sanofi, the company who produced clopidogrel. The first step in this mechanism is the formation of methyl ester. Continued refluxing with chlorinated mandelic acid with methanol in the presence of hydrochloric acid prepares methyl mandalate. The product formed is chlorinated using thionyl chloride, which leads to the formation of alpha chloroacetate. The latter was then displaced with thienopyridine through an SN2 reaction, which finally led to the formation of the drug's final structure. The problem found in these methods was that they produced racemic mixtures. This was problematic because only the dextrorotary clopidogrel variant was the active component, and the levorotary clopidogrel was the inactive component and had no binding interactions with the P2Y12 receptor. This problem was overcome by treating the racemic mixture with levorotary CAM410 sulfonic acid in acetone to form SALT-19. This was recrystallized from acetone to produce an enantiomerically pure dextrorotary clopidogrel. This is the current way of synthesis for clopidogrel on a large-scale setting. Atherosclerosis is where a plaque develops in the blood vessels. This can be very dangerous because it causes an increase in blood pressure, subsequently increasing the risk of stroke, ischemic heart disease and aneurysms. Atherosclerosis develops when low-density lipoproteins, known as LDLs, are deposited in the blood vessels. LDLs will eventually become oxidized, and this initiates a chronic inflammatory response, recruiting leukocytes, macrophages and lymphocytes. It also activates platelet adhesion, a critical step in forming the plaque. Platelets aggregate via the binding of ADP to the P2Y12 receptors. The adhesion of the platelets acts to direct the inflammatory cells to the plaque. The platelet also carries a significant amount of stromal-derived factor 1, known as SDF1. SDF1 is a potent chemokine for the cells recruited in the inflammatory response.